There we go. So the next skill is, I taught you how to find the components of an angle magnitude vector. The next thing is to show you, if somebody gives you the components, how do you make the angle magnitude vector from that? You do the opposite of it, right? So let me just show you this, okay? So, for example, if somebody, whoa, what did I just do? Okay, if somebody gives you, can we be quiet right now? All of us? All right, so if somebody gives you this vector and it's 5.1 meters in the x direction plus negative 1.7 meters in the y direction, that's a perfectly good vector, component vector. We're now going to make it an angle magnitude vector. And the first thing to do, and this is the hardest thing, is to draw the vector. Okay, I never imagined that this would be so difficult, but it apparently is. It's the hardest thing that we do. Because you guys are all really good at the Pythagorean theorem, and you all can follow simple directions with a calculator. Okay, so when I draw this thing, can everybody just point your eyes up here, because this is what I need to teach you apparently. Okay, so when you draw this, you're going to draw them without picking up your pen. Okay, it's just like the Where Am I exercise we did. This is like a treasure map, only it's only got 2 instructions, yes? So this is 5.1 over 1.7 down. Notice that 1.7 is shorter than 5, right? So draw shorter ones shorter, longer ones longer. Now, the vector does the same thing as the components. These are the components of that vector. So the components started here and they ended there. What's an arrow that does the same thing? Yeah, down and to the right. Okay? Okay, so notice that the components are tip to tail, right? But the vector itself starts where they started, ends where they ended. When you make your drawings for me later, make sure that your hypotenuse, that's the slanty line, okay? Make sure the hypotenuse has an arrow on it. It's got to have an arrow on it, okay? Now all we have to do now is find the angle and the magnitude, yes? Okay, so let's find the angle first, because it is an angle magnitude vector, right? So that angle there, notice that, I'll just use a different color ink. This side is opposite that angle. That is, it doesn't touch the angle in any way, right? And this side is the adjacent side, right? And then I'm going to use, to find the angle, right? There's the thing called tangent, right? So there's 3 buttons. There's sine, cosine, tangent. Cosine's for the x component. Sine is for the y. Tangent is for finding angles. Math teachers would cringe, but that's what I use them for. So the tangent of that angle is, it's always the opposite over the adjacent. So the angle is therefore the inverse tangent of opposite over adjacent, right? And again, the opposite side is the side that, if it's big, it makes the angle big. Does that make sense? That's the opposite side, right? And yeah, it's SOHCAHTOA, right? So in this case, my angle is tan minus 1 of the opposite is 1.7 over 5.0, right? And then if I do that, and I am in degrees, and this is how you can find out if you're in radians or something, right? Because it'll be like 0.17 or something like that. So second tan, when you type it into your calculator, you go second tan, and it burps up tan minus 1. Then you go 1.7 divided by 5.0. Try this right now. Let's find out if your calculator is doing that. Okay, so inverse tan, 1.7 divided by 5.0. This number should be bigger than 45 or smaller than 45?
Smaller.
It should be smaller, right? Because it's the way I drew it, since I drew it somewhat to scale, we can tell it's an adorable angle, right? Oh, 5.1. Oh, yeah. How did I get that? Because I'm a spaz. 5.1, 5.1, 5.1. Let's do it. Okay. And now I got to change it in my calculator, too. 5.1. And that's 18.4 degrees. Do you get that? If you're getting some decimal like 0.17, you are in radians. And you need to go mode, go down with the arrows and get yourself over degrees. And is that working out for everybody?
Yes, sir.
Check it now. Everybody every person in this room should have typed that into their calculator and gotten 18.4, 349, 488, 229, or whatever. Yeah? Approximately. Are we good? And then the final thing, it's an angle magnitude vector, right? So now we've got to do the magnitude, right? We got to do the magnitude. Well, the magnitude's easy. It's just the hypotenuse, right? So it's c is the square root of a squared plus b squared, right? Okay, so this thing, the magnitude, is the hypotenuse of the vector, right? So it's the square root in this case of 5.1. We'll get it right this time, plus 1.7 squared, right? Now notice that that one's negative, and I never put the negatives in here. I don't need to. Once I've made the drawing, I don't need the minus signs in there. And then the other reason I'm not using minus signs is that your TI calculators do suspicious things. Like, for example, if you square -2, you get -4, which is wrong. Okay? So it interprets it as the opposite of 2 squared, which I don't believe is a correct interpretation. Okay, so square root of 5.1 squared plus, and this is 5.37, 5.3, I guess 38. Right? So if you made this drawing, if you labeled that angle and said that angle is 18.4 degrees, and that this thing here was 5.38 meters, and you drew the drawing and it was down and to the right, that I knew which way it was, that it was down and to the right, you labeled which angle you found, and you labeled the hypotenuse, then we would know that you can make an angle magnitude vector. And to the extent that you can't, why, there it is, right? It turns out that our biggest problem is actually this drawing. So let's practice some of these, and then let's not practice too long, but just the right amount.